I said I'm going to talk about CocoaPods, and CocoaPods is a dependency manager for iOS. It's you'll have seen things similar in other languages, you'll have seen other tools that do the same kind of things, but I wanted to talk about what kind of makes CocoaPods unique. So this is our beautiful logo, and I guess before I get started, I just want to talk a little bit about myself. So I'm big on open source. I do large amounts of projects ranging from sort of client work, which is building applications for kind of this place, showing art galleries around the world, and I do iOS apps that look stunning with no blue, that are open source, that you can buy online, that allow people to download and trade media. Really fun stuff, lots of cool things that are going on. And my work at this point now pay me effectively to work on things like CocoaPods and open source libraries, as well as doing some of this kind of stuff. So what I want to start with is giving you guys a bit of an idea about how CocoaPods got started. I was talking to another developer at the big CocoaPods meetup that we do every year at WWDC, and he said that there were essentially 3 stages of developers working with Objective-C. You had the people that came from Next Step, and these were the guys that built the runtime, they built the compilers, they built all the foundations, they built all the libraries, they built all these really kind of computer science heavy applications, and a lot of the core foundations that we need and still use every day. Like if you're an Objective-C developer, you'll recognize the NS from the beginning of all of your core kind of language foundations. From that came the Mac developers. These were guys that usually were ex-Apple. They were big on making these well-crafted, beautifully designed applications, but they were not big on open source. There was very few large-scale applications on the Mac that were A, open source, and B, kind of used by many people. The only major success story for open source on the Mac at this time was really Adium, which is a chat client that I still use now. It taught me how to develop on the Mac probably about 6 or 7 years ago. And then we kind of ended up with, oh yeah, I've got the logo, so that was next. This was the Mac developers, in pretty pink. And then we had the iPhone. So this is effectively like an influx of all these new code immigrants. These were people that had come from all these different generations. They've come from the enterprise, they've come from Windows, they've come from Ruby, they've come from the web. And they've come in with such a different level of expectation about what the tooling should be like and how the language should act. And Apple have both reacted to this and not reacted to some of this. So there was a big simplification of the language where they took out memory management, they took out they simplified the messaging syntax to use dot notation instead of always having the square brackets. And these were ways of making it more accommodating for people that are coming in with these new fresh ideas. And what it's really done is kind of expose some of the weaker points of building these applications. And before CocoaPods, effectively, there was very few major open source libraries that people could work with, that people could take and just make. Even small trivial ones would mean that you'd have to go in and do a lot of manual work in order to just take someone else's code. So in my humble opinion, and because I work on CocoaPods, I believe that CocoaPods really is the tentpole for Objective-C's open source community. Tentpole is like a metaphor from the movie business, wherein you have like one massive summer blockbuster which kind of brings everyone in, and then it kind of raises the tide for all the other movies. And it feels like this one project effectively makes it so that everybody can quite easily download, put up their own open source. It will force them into quite a rigid structure for how libraries should be maintained and how libraries should be created. And by doing this, it's really made people work harder, do better, and we found that when looking at the before and the after with the community, there's been a lot of change. So I'd like to talk a bit about some of the competitors that we have to CocoaPods. We have Bower, which is like a JavaScript version of dependency management. There's Nugget, which is a sort of .NET version of it. RubyGems and Bundler are other kind of ways of dealing with these package managements. And they all take quite different approaches. So RubyGems, for example, hosts all the source code themselves. This became a problem probably about 6 months ago when they found out that they'd been hacked, and they had no way of finding out if people had gone in and actually edited some of the source code that could then have gone to potentially every single person that has downloaded a gem from them. Bower has taken a lot of ideas from us, wherein we try and make sure that a lot of the source code is actually hosted by the individuals themselves that are the library maintainers. Which I think is quite a nice way of doing it. It's the same with homebrew, but I don't think they have a logo, so I didn't put them up on there. So what I wanted to show you, because I'm almost getting to the explanations of really what CocoaPods is and how it works underneath the hood, is a video of basically what you would have to do if you were going to try and use an external dependency in your own code when you don't have CocoaPods. So what this was basically is you have to Google for it, you have to go and read the README, you have to do all the project settings, and you have to drag everything in. I think it's like a minute or so long, so it shouldn't be too bad, and I'll just talk it through as it goes on. So I'm just opening my test app to see if it's there, jumping into Safari, then doing a search for an iOS networking library. I find one, then you've got to then go to the project page on GitHub. That then tells you to go to a different page on GitHub. You then have to go find yourself a get started. That will then tell you to go back and clone the repo so that you can then get the files down onto your local hard drive. You then start reading through the README, and it will tell you that you'll need to go and copy some files in. Once you've copied some files in, then I'll give it a second to copy some files in. And this is at 3 times speed, by the way. If you were doing this for every single dependency, you ideally should also be noting, what specific SHA you downloaded it from, so you've got an idea of what your versionings are internally. You've got to make sure that your exact settings are what the library expects when you're importing things. It is a bit frustrating. And then when you get compiler errors, you have to go back to the README, you've got to go and check to find out exactly why this happened. Got to do your individual build settings on a per file basis. So in this case, this is making sure that the project itself complies with Arc, which is a memory management tool for Obj-c. So I'm going in and adding no Arc to all of these specific files. Arduous. And I think that's it. I think then just go back and it says, congratulations, you can build, and you get build succeed. So that is a speed up version of how you would be able to download a networking library, integrate it with your project. Got to read the README, got to download all your files, do all your build settings, and effectively CocoaPods is a way of trying to not make this so much hassle. So one of the things that we're going to see here straight away is that we have a built-in search tool for every single CocoaPod. I use a flag on the command line tool that will then actually go and check GitHub to see how many forks and how many stars each individual project is, so you've got a better way of kind of discovering more interesting projects based on stuff like this. So pod searching for networks, I get to just search through the ones that I want. Again, you can just select the text. I'm going to create my pod file, which I'll explain later. I want to say what platform I'm using, say that I'm using AF networking, then I can just say pod install. It will go and do all the stuff that we did in the last one, where we do individual build settings, download the repo, copy it in, and in this case, I'm already done before I could even explain what was actually happening. So when you're doing this with multiple libraries, this gets very, very arduous the old way. And so CocoaPods tries to sort of simplify this. So CocoaPods is now 2 years old. We're getting to be quite a mature project. In terms of open source projects, we've got an awful large amount of contributors, 1,400. This ranges from people just saying, you should make a tiny edit to this dependency, to someone submitting an entire pull request that takes 6 months to merge. We've got 2,300 libraries. In comparing with some of the other examples, it turns out that's quite a small amount. But I think it's because we have a very small community. When I went and looked at some of the statistics from Apple about beta downloads from iOS 6, they announced that there had been about 100,000 downloads of the actual betas, which, whilst not being specifically stated, this is how many developers there are for the platform, it's a rough idea of how many sort of active and interested developers we have in the community. And of course there's like journalists and kids that want to be on the latest edge, but I think that it's a pretty good amount of saying, roughly 1% of the community contributes to open source. We've had 4,000 pull requests in the last 2 years. Almost every morning now I wake up to about 20 to 30. I've had to build built Safari and Chrome extensions for dealing with these. We have people that have built specific iPhone apps just to deal with like the amount of traffic that we actually get. We deal a lot with Travis CI, so if you've ever used that, it's a constant integration server that's kind of open source based, and if you've got an open source project, then they'll do it for free. And so we've been stress testing Travis CI since it came out that they did Mac versions, and we have 6,000 pod specs. So a pod spec is an individual recipe for how you can actually download a open source library. And yeah, we have a lot of downloads. We found that there's some irony in that CocoaPods is a dependency manager, and the only way that you can install it actually is by using another dependency manager. Ideally, at some point, we would like to move that into like a static binary that you can download and it'll just all work. But for now, we've been using the gems in infrastructure to actually build our own package manager tool. It's like with Python. I don't know if any of you have used it, but you find out like when you install it on a Mac, the first thing you need to do actually is use your easy install package manager to install pip, another package manager for Python. So I mean, it's a nice way of doing it. Cool. So before I get started on like literally what CocoaPods is and how it all works, I've been working now for about 3 or 4 months on a big rebranding, a big redesign, and it's mostly in black and white, so it should kind of work with no blue. I think if it's like bright green, then it's not right. But so I really wanted, I know quite a lot of you guys may not have even heard of CocoaPods, so for you it's not particularly new, but for a lot of people this new logo is kind of interesting and controversial. But for me, it felt quite awkward writing all these slides using the old kind of design, but again, it's a bit green for you guys, but I just wanted to move into kind of a new feel. The idea being that if CocoaPods is this tent pole for the Objective-C community, we need to really show that you can have these beautifully designed open source projects that can also help everybody. Because you can go and look at some of like the JavaScript people, and these have these beautifully adorned libraries with amazing design work. If you look at the jQuery Foundation now, like they have maybe 6 or 7 ginormous websites all beautifully branded and that match all their style and how they all work together. And I kind of feel that if CocoaPods is going to be this one thing that people think in the Objective-C community, like I want to be a part of this, And I think that having a really good, strong branding will work for this. So we've already talked a little bit about what problems does it solve. It's kind of cropped on the end. For me, it's always solved this problem in that you want to use Git submodules to deal with your dependency management tool. So that allows you to quite happily separate out, your externals into a different file or folder. It allows you to update it completely separate to the actual main application code. But it can get quite complex. I've worked in a project where we had Git submodules that were nested 4 layers deep, and it was not fun at all to update one right at the end of one of the leaves of your nodes. So this gets rid of Git submodules for you. It allows you to do things like not having any of it will chop out any of the files that you don't actually use. So let's say you download AF networking, which we saw earlier. Doing that as a Git submodule will actually pull in the example code, it will pull in the change logs, and it will pull in the README. But that's probably not so relevant to your actual project. So you would end up just copying in some of the specific files into your project, but in reality what you really want to be doing is just cutting them all out, and that's what CocoaPods does. It then deals with dependency versioning, and as I mentioned earlier, with a 4-level deep Git submodule hierarchy, in terms of dealing with dependencies, this gets quite complex once you have multiple applications dealing with the same dependency that may then actually need a different sub-dependency inside it. CocoaPods allows you to give say that one dependency will need X, Y, and Z, and another dependency might only need X, Y, and so it will resolve the issue for you just as you'd expect. But this comes really useful later on when you come to a project for maybe the second time to come do some maintenance work on it, because it means that the libraries themselves may have changed, and all you'd have to do is say do a pod update, and pod update would automatically go and look, find out what updated versions of the pod files that you already have, deal with them within the actual understandings of where your dependencies kind of their upper limit and their lower limits are, and it will see if it can update it for you, which can be super essential for getting all the bug fixes. And for me, one of the biggest kind of advantages of using a system like CocoaPods is that it allows you to separate your external code from your application. How we do it is we create a separate project in your project that's only for CocoaPods. We try and we automatically make it so that you can't put that into version control, but you can remove that. But effectively, all we do to your actual application code is throw everything into a single folder called the pods folder, and then make one tiny change to your actual application in order to make it link at the end. And this provides a really solid, clean separation between the stuff you're working on and the stuff that you're not working on. We have ways of making it so you can use pods for development, which I'll get into later, but effectively it allows you to have a very clean separation of what you think is read-only code and what you think is your read-write code. So it turns out I'm actually about to talk about development pods. So pods are read-only. We don't think that you should be editing your dependencies. In things like rubygems, your dependencies are very well hidden away. You'd have to go into a system folder down in your terminal to go and actually edit these. In CocoaPods, we expose them to you, because when you're dealing with a statically linked application, then when you've got crashes and things like that, you want to go exactly to the line, and you want to know where these problems are coming from. But it's kind of a bit of a bad practice to edit your dependencies. So what is generally normal is you can then go and fork it and have your own repo where you've got your edits, and then you've got a versioned version of your edits based on someone else's library. Then there's handling all the compiler settings. You saw earlier I added something called Obj-c arc, which is a compiler flag that says don't use arc. But a lot of libraries have a lot of very complex compiler settings, and once you start mixing and merging these, it gets very, very complicated. Things like Obj-c all load, or saying like defines that are important to your actual code base. AF networking, for example, has one that's that ensures that you use a specific type of SSL certification, and without using CocoaPods, that probably wouldn't be on by default. So we don't just do that too. We also allow you to do things like pre-install and post-install hooks. So for example, Spotify, the Spotify library on CocoaPods will check to see if you've already installed the Spotify library in your kind of /user/bin, I think. And if it's not actually installed the C library, it will then go and run an install script, download all those, and then it will allow it to download the actual pod. So we allow you to have not just complex application-based hierarchies of code, we can actually then pull in external libraries and do updates and things like that. Again, it's trying to automate as much as possible. We ensure that all the pods are validated server-side. So I mentioned earlier, like the rubygems people have the problem whereby if someone goes and edits any of the rubygems, there's no validation that it's not been tampered with, or that it might actually hurt your system, because a lot of these dependency manager tools all rely on being able to execute arbitrary code on your computer as a developer. So for example, if someone released a version of a very popular networking library, and that included some malicious shell script at the end to update, to pull off your source code from your computer and to upload it to some Russian server somewhere, that could actually happen. So we have this kind of validating linting service which goes through and checks every single pod every time someone does an update, which is every 30 minutes or so, that will ensure that all of our actual data is up to scratch and not actually going to harm other people's computers. It's a really useful feature, and we're trying to kind of move away from this. We're trying to move into using YAML instead of like raw DSLs in order to kind of simplify this. And it avoids a single source for all source code. CocoaPods is a collection of Ruby gems. We have a very cool one called CocoaPods Downloader, and it effectively is a system for downloading arbitrary source code. So this could be tar.gzip files on some HTTP or FTP server. It could be in a bazaar. I don't know what they call them. I think they just call them shars in bazaar. It could be on some HG tag. It could be in a Git repo. It could be on Subversion. And we're totally version control system agnostic in terms of major open source ones. I'm pretty sure that something like Team Foundation isn't supported, but maybe if Microsoft open source it. And this gives us a lot of freedom in terms of how people use CocoaPods. Again, to use a Spotify example, Spotify have a HTTP zip file that we just download and we unarchive, and then we extract the source code from that. Whereas something like AF networking is a Git repo, and we go and pull it from the tag. And you can have all of these, and this is particularly relevant when you're dealing with private repositories of pod specs. So I think I get onto that a little bit later, but it's a really interesting aspect of the project. So what I wanted to show you guys is a pod spec, and I actually get to use my laser pointer. So this is how you would define a pod spec. You would create one, you'd give it a title, you give it a version, a little description, and you say what the website's from. We enforce having a license on every single piece of code in in our repositories. So you cannot release a CocoaPods pod spec to the public unless it is licensed. It doesn't have to specifically be an open source license or anything like that, but it has to have a license. In this case, I'm referencing BSD, and I'm stating that the file is in this place is in a file called license. One of the cool things that CocoaPods does that a lot of the other dependency managers don't is that we'll go and generate a markdown version of all of your licenses as a single file, so that you can kind of display that in order to comply with a lot of your licenses, because a lot of your licenses require, you should show this license with your application, especially if it's going to be statically linked. So that's basically what the BSD one does. So we try and generate what we call the acknowledgements file by looking through all of your different licenses from all the code that you've got as external dependencies, and then we generate one simple file for you guys. Super useful feature. Once people find that, they get super excited about the actual project, because that's another thing that people miss. Including all your licenses and stating, this is what I support, this is built on X, Y, and Z. Ooh, it's a blank one. Okay, so how do we do this? So I talked briefly about how we resolve dependencies. We have all these do I have one here? Yep. So you can see some of my dependencies here. So in this library for downloading subtitles, we require a networking library, and we state here that we require at least version 1 and above. So in this case, this will go up to 2. It takes the second least significant kind of digit, and then uses that as the do not go above this marker. So I can look at this and say it's going to include XML RPC, any version, so there's no actual checking of the versions in that case, but it will make sure that it will not accept version 2 of AF networking. So it will resolve all your dependencies, and once it's resolved all your dependencies, it will create this file called the podfile.lock, which we'll come to later. But that is effectively this one single file that tells you which exact versions were used the last time someone built this this app with these pods. This means that, once again, let's say you leave an application for, say, 6 to 10 months and you come back again, when you do pod install, you want to be able to get the exact same version as the last version that you had. Or if you're working with multiple people, then you still want the exact same version as other people. And so we have something called the podfile.lock, and the podfile.lock basically is a collection of very specific SHA data and very specific version data, which we'll get to later. So once we do that, we go and fetch our library sources. And as I said earlier, these are version control system agnostic, so it could be Git, Bazaar, HG, HTTP, Subversion. We effectively allow as much as possible, because people want to have their source code how they want to have their source code. And then we collect all the build settings. Again, I'll show you an example of how we do this, but we want to make sure that each individual library is kind of siloed into its own area, wherein it cannot then have its build settings affect another library. Because, again, this is all compiled code, so if you, for example, were just not using CocoaPods and you were dragging all your dependencies in, and you were then having these build settings that could be very, very long, you would also find that some of them would clash. Some libraries might not work with specific build settings, whilst others do, and it gets quite difficult to make sure that all of your build settings are not conflicting. So we deal with this in an interesting way, but I'll get to that later. And then we create an Xcode project. Arguably this was one of the most controversial moves for CocoaPods when it first started out, and probably one of the major reasons why people hadn't made the project before. Because, I mean, we're using we have two ways of doing it, in fact, I'll explain. The first way is we try and copy Apple's specification entirely for building an Xcode project, which is a specific type of Well, now it's more like a JSON file with a little bit of extra details around there and some comments in order to make sure that the ordering is correct. But this is totally fragile. It's literally, it could just break any time, because anytime Apple make an update to what the actual project style is, potentially that could break CocoaPods. We built another tool which is probably even more of a hack. Actually then, if Xcode is running, we'll use Xcode's private API to generate an Xcode project at runtime that will then use that as the main externals project, which is really cool. And so far, we haven't put that out to too many testers yet, because it's very, very liable to break. But it's a really interesting way of dealing with how do you create a file with a format that's both closed source and very liable to change at any time. And then finally, we have user integration, which is, we don't want to be touching your project as much as possible, because it's your project, and quite rightly, a lot of people are suspicious of a project that runs on the command line that will automatically make edits to your own source code, and it feels a bit magic. It's one single line that you write that says dependency, you do a terminal command, and then suddenly you've got two projects and you've got a different file to open every time instead of the original. And we really want to try and minimize the amount of touching that we do on your code. So you can do a diff, and if you do a diff, which I should have taken a screenshot of, but it's basically, we just add a single config file, an Xcode config file, and we link in the same way that you would link to any normal library with the CocoaPods one. So yeah, touch it as little as possible. That's funny, because this black here is exactly bright red, so it just looks like the same color as everything. So this is how you install it. In terms of Objective-C developers, there's still a bit of stigma towards jumping into the terminal and playing with things. As I said, it's most likely that, again, coming as code immigrants, for us, a lot of the terminal commands are exactly where we're comfortable. So luckily there's people that disagree, and they build tools to allow you to just run CocoaPods there and then in Xcode. Again, this is not officially supported, but I do have some really great ideas for how we can make CocoaPods feel like a really natural part of Xcode. But we still, it's still hard to build an Xcode plugin to the kind of quality that we want it to feel. Like people, we want to let people know that it exists, but we don't want people to entirely rely on a hacky Xcode plugin in order to then use CocoaPods. But it works. I use this, and I really like this install docs during integration. I built a tool called CocoaDocks, which is a tool that will create documentation for every single open source library in Objective-C. So that's 6,000 different versions, and I think it's about 30-40 gigabytes worth of data now. I originally used to build it on my laptop, but eventually moved on to a Mac Mini in the sky. And this effectively allows documentation to be running in line in your Xcode. Very cool. So this is an example of a production-ready pod file. Sorry. So this is one from my work. This is one of the ones that I use when I'm building apps, and it shows some interesting stuff. So if we look at the start, straight away we know exactly what platform and what version is the minimum supported, and then I inhibit all warnings. So my opinion, again you guys can have different ones, is that external libraries are external libraries, and I do not want to see warnings for external libraries. Now again, it's an option, and there's an exclamation point to let you know that's a pretty serious move. And then you go through and you can describe all your specific versions. So in this case, I'm quite sure that I want 1.6 versions, so that would accept 1.6.3, 4, 5, 6, 7, but it won't go to 1.7. Whereas reachability, I know it won't change very often. They certainly won't be changing the API for that anytime soon. But then we can see DD Progress View and Zip Archives. These are projects that I had to make changes to. So again, as I mentioned earlier, it's not very good to go in and actually start making changes to your actual project, to your CocoaPods pods. So you should fork them. You fork them, make your changes. If you want to, you can send a pull request to the original owners, and maybe they'll update the original version. Then you can go and change that to not say this anymore, but actually have a specific version. But in the meantime, you're in total control. So I personally leave them on my forks. I think I've submitted the pull request to both of these projects. Pretty sure they went in, but I still haven't moved them back. And then you can see like these are my projects, so I want them to always be on the latest, so I also don't specify a version. And then at the bottom we have like unit testing, so you can have multiple targets in an Xcode project. So let's say you're building a library that then builds your application, so you might have library, application, unit testing. So you could potentially have a lot of different targets in here that might have only specific pod files, specific pod specs. So in this case, Kiwi is a testing framework, and it's totally not relevant to my application, but it's very relevant to building unit tests. So we allow you to kind of scope which way your dependencies go. So this creates the podfile.lock, which we were talking about earlier. This is the very specific version that tells you exactly what you downloaded and exactly what someone else should use if they're going to share your code. So if I deleted this file, the next time I ran a pod install, it would go and download all the latest updates that it possibly could, so it would get all the patches. But until then, we're stuck on these exact versions, and I know that right now AF networking is now at 1.3.6. So I mean, I could do a pod update to get that changed, but I'm not going to until I go back to work on this. So this is what it ends up looking like. In this case, 37 targets. So each one of these is your pod. Some of those can then have some dependencies of their own, but they all still get thrown into this single project over here. Nice, simple, and easy. And I do not have any development pods in here, but they would show up in this area too. So I don't have any screenshots of development pods, so I guess I'll explain how they work. Development pods are unique in that, as I said earlier, if you treat all pods as read-only, sometimes you don't want to treat a pod as a read-only. You might want to be working on a library whilst at the same time using it in your apps. And so what we allow is effectively a file-based CocoaPod. So instead of going to the server, do I have the pod close? Yeah. So instead of, there we go. Instead of going to this server here, and then pulling in the files, deleting all the other ones, and cleaning up all the stuff, it will actually go to a folder, not delete all the stuff, but only pull out, well, not even pull out actually, it'll create aliases to the actual source files that it references, so that any changes that you make will actually go straight back to that local folder, and then you can just use your version control system as normal. And that allows you to easily make edits and allow those to be changed up without having to go through the whole rigmarole of changing to your own fork, making the changes, pushing that up, doing a pod install, having them come down. Development pods are really useful, especially when you start using private repositories. So to jump back to where I was, downside of having animations, we were here. So yeah, the way that we handle all the settings is kind of interesting. We use an old tool that used to be used a lot in like the next step days, which is called Xcode config files. In order to try and make sure that we're not hiding all your build settings in all these different places, what we have is one big file that shows all of your major changes, and then we allow sort of Xc configs. So again, these are read-only, so changing these would automatically get overwritten the next time you did a pod install, but we have ways of allowing CocoaPods to actually make edits to them themselves. But it allows you to see all your build settings in one place. And again, when you've got a large amount of CocoaPods, as it says here, I've got 37 individual external libraries. That's because they're doubled, because I've got 2 targets. And then the extra odd one is the actual pods itself. It means that, for example, which one? I've got the zip archive. This has a very specific compiler flags to ensure that you include a specific type of libzip. So that again is in an Xc config. This sort of stuff is hard to find initially, but once you actually see that it's quite a simple system, it means that you can actually make these edits quite easily. So this is been how you actually deal with it. What I've been spending a lot of time on lately is trying to figure out how do you make discoverability easy. So I've been working on a new website for CocoaPods, which is not all in black and white because we use red a lot. It relies a lot on trying to rethink how do you search and how do you explore and how do you rate a project has been my main focus lately. And to give you guys a brief up and show you how it feels, it's quite a nice website. It gives a very nice impression of the project that's been going on for a while. We do the same when it comes to the mobile, because it turns out people use mobiles that build iOS. But what I really wanted to show you is this, the way that we've been thinking about search. So one of the hard things in dealing with libraries and trying to do discoverability is that it's very, very subjective. All of these networking libraries have their own positives and negatives, and trying to decide, for CocoaPods to try and decide for you is kind of not the best solution. So what I've been looking at is all these different metrics on a library, trying to understand how do you figure out whether it's something that's relevant for you. So some of the key metrics I've been playing with are things like how mature is the project, so how long has it been gone, how many stars has it got, how many forks, because I built a tool for generated documentation for every single open source project. That means I have an idea of how well documented the entire project is. So that also is something that we can throw in there. We can also then talk about, how long is the README? Is this a detailed README with some installation instructions? Does it tell you how many people are involved in the project? Usually the length of the README is actually quite a good indicator about how much time and effort has been spent on actually making the library. Again, really cool, really cool. Someone gave me an awesome idea yesterday, but I think I was drinking too much that I forgot it. Do you remember this? For one of the best ways of determining whether a project is relevant. No, I can't remember. But regardless, we're gonna... I know, it's like one of those things. When they told me, I had to think, I've got to rethink the entire concept. Now I don't, because I've already forgotten. So yeah, we'll show things like the README in line. We'll show like screenshots in line. You'll be able to see almost everything about a project without ever having to leave this search interface effectively, and that will boost discoverability of the smaller libraries at the same time. Like, you do a search for something like blocks, and you just get so many results back now in the pod search interface that it's just not that much fun to actually go through and look. And at the same time, because of the limit of the amount of information that you have available at this point, you can't make a solid assumption about which is going to be the most relevant to your project. So I think that this kind of revised search, wherein we provide a lot of context for you, the users, means that a lot of people will be able to find things that previously they might have just missed because they'd have gone with the most popular project. And in Objective-C, until very recently, the most popular project was a project called 320 by Facebook, which has been discontinued now for almost a year, and like they really don't want anybody to use it. Now they've gone and deleted the source code from GitHub because of this problem of it being considered the most popular project on GitHub. And so this is the sort of problem that I'm trying to solve with dealing with searching. Again, it's just showing you some nice results, loading more. These are how we feel it should work on the mobile. Again, nice, simple, easy, and really, really cool experience. So we've not just been looking at search, been kind of looking at how we can deal with letting people know about the project updates or best practices. Again, because CocoaPods is this tentpole, we get to be a little bit pushy. We've said specifically this is how we feel that iOS and Mac libraries should kind of standardize. So we have a set project that people kind of clone that creates a kind of like a bootstrap for iOS, I guess. It does things like gives you a README, gives you a changelog, gives you rake commands. Rake is again another terminal command thing, but it automatically allows you to deploy to CocoaPods, to deploy to private repositories, to kind of give you this great start in where a project should be and how a project should act. And because we've been doing this, we've been trying to find ways of dealing with, how do we get communications out? So we've been playing a lot with blogs. Start writing a CocoaPods blog, and we want to try and use this same kind of feel and for the guides and for the general system. Again, big fan of this. I think it's going to be a really nice way of presenting information in comparison to using Twitter and using our changelog, because one is too transitory and the other is too technical, so a lot of people don't read the changelog. And I guess I just want to point out that there's a lot of us involved in the project, and as I said earlier, there is 14,000 people, 1,400 people involved in doing this, and so I went and grabbed all their gravatars, and you get to just do this for a long time before you start to go through everyone that's actually done some contribution to, I like that guy, to this project. And it's really nice to be able to just to work with so many people, to interact with so many people, and to see so many people with a passion for the actual community. So yeah, that was me. I'm Orta, and that was CocoaPods, and you should follow us both. So thank you. Okay, cool. Alright. Isn't there a danger that CocoaPods makes devs ignorant of how you use Xcode to integrate projects? I like to know how things work in case I have to fix things, is the first question. So, yes. Yes. There is a danger of that. There is a big danger of that. Because CocoaPods feels like magic, as I said earlier. You type a command line in, and bang. All your system has changed slightly. We've created a separate new project in the pods file, and it's hard to kind of say at what point should we be explaining every single part of the process. There is a guide on our CocoaPods wiki that literally shows you every single step we do in order to create both the project and all the changes that we make to your project. But again, this is hidden on a wiki page in the middle of, we have 20 odd separate repos in the CocoaPods repository, CocoaPods organization, and it's hard to find this sort of stuff. So this is exactly why we've been building the guides website and the blog, to try and explain to people in a way that will always be relevant. So like the wiki, at some point we'll have to delete that in order to make it in the guides, but anybody can edit that wiki versus us that can control some of the guides, so we can deal with it in pull requests. So yeah, it is a bit magic. There's no way of not doing it in a magical way. The only way of not doing it in a magical way is to have Apple do it, and we've waited 12 odd years for Apple to do it, and so yes, the community took a stand, and unfortunately the only way it could work is by involving some magic, but it's not that magical. I did a talk a week ago with the guy who actually writes a lot of the underlying code of CocoaPods. I mainly kind of sit on the top and do a lot of the design work, figure out what are the interactions, how should people be using the project. And his entire talk was to explain all the underlying principles to make sure you guys have an idea of how it works. And the slides for that are up, and there's notes for every single slide. And I definitely recommend looking at that if you don't want to look at the guides to understand how and why it works. Okay, in Java for Maven, I've never used this, but it keeps coming up, so I would like to, if anybody, whoever asks this, come and talk to me as well. I'd like to know a bit more about it. So private Maven repos, is it possible to have your own Postgres library for in-house modules? Yes, very much yes. Super simple. In our case, you just create a Git repository or whatever. You should probably create a Git repository for it, and you can just put your pod specs in the same system that we use. There's probably about 9 to 10 blog posts from other people that explain the entire process. We have a CocoaPods guide that's been built that's not out yet, that specifically shows the process from top to bottom, saying how you can have a private repository, how you can deal with updates automatically, the command line tools that we built to make that really simple. Yeah, private repos are like a #1 priority for us, because I don't use them there, but I use them in some other projects, all the other devs use them in their own projects. Private repos are super important. Test free, that's a good question, that one. Questions work. So how do we handle clashing versions? That's an interesting one. So okay. There's 2 answers to this. There's the simple answer, which is we don't, and there is the less simple answer, which is a little bit vague. So because of the way that our dependency manager works, we start at the top of the file and we work our way down. If you specify yourself which version of a library you would like, you can entirely avoid the dependency manager trying to figure that out for you. The biggest problem here is that you got a call. The biggest problem here is actually that we're using a statically compiled library, and we can't do a version that only works for one specific library. So we can't have version 1.5.1 of library X as well as 1.4.9 of library Y of library X in the same project, because you get namespace collisions. There's been debates about whether we can get around this by applying prefixes to every single pod, but that gets even more complex, because then whenever you are actually using any of these versions in your own code, you have to apply the CocoaPods namespacing before, because the Objective-C runtime and the entire compiler stuff don't support namespacing. So until namespacing exists, then we just can't build that feature. At least in a way that's totally acceptable to everybody and people that are used to kind of dynamic languages that allow this kind of namespacing. Big shame, but it's on our to-do list before version 1, and I've been told that version 1 will be out before a year, so I think it's a hard problem that we'll be solving at some point now. Is there any more questions, or was that my last?
Yeah, but I think we'll cap it there.
Okay, that's fine.
So everyone, remember to vote, and have a good lunch, everyone. See you here after lunch.
Ciao, ciao.